These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There is a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. By the way, I also offer tutoring via Skype, and you can find more information about that Skype tutoring service at my website. Thanks. Looks like you already did part A.
Yeah.
Okay. Well, go ahead and refresh your memory for part B. Tell me if you have any ideas about how to attack part B.
For n equals 2, L is 2.
Does L have to be 2, or is that a possible value for L?
Is it possible?
Right. What are the other possibles? Remember, the question is asking how many states are possible.
Wait, would it be 2 or 1?
Oh, yeah. I guess we both made a mistake. So yeah, it's not possible for L to be 2. What could L be?
1, 0, and -1?
I think you might be getting some of the different variables confused. Okay, let's review that.
Oh, L can be 0 or 1.
Right. Now actually, as far as I'm concerned, the easiest way to do this is, let's go back to our periodic table. I think we marked this up last time. Which block would we call this?
1s,
Right.
2s, 3s, 4s, 5, 6.
Good.
That's 3D, 4D, and that's 1. That's 2p, 3p, 4p.
The very easiest way to do this is just to count how many columns are there in the second shell. So which parts of the table here? Which parts of the table here represent n equals 2?
The 2s and 2p.
Yeah, and how many columns do they have?
2.
How many columns total in the 2s and the 2p shells? You need the periodic table.
Okay. Wait, what do you mean columns?
Well, how many columns are there in the 2s block?
Oh, 2.
And how many columns in the 2p block?
6.
How many columns
8.
overall? So how many electrons would fit total in that block?
16.
How many electrons would fit in the two? Each column represents 1 electron. Each column represents
so
1
8
electron.
electrons?
8 electrons, that's right. You might be thinking 4 orbitals, 8 electrons. The number of electrons is twice the number of orbitals. But the columns indicate the electrons. Why can it fit 8 electrons? Because there's 8 possible states when n is 2. There's 8 possible states when n is 2. So that, for me, that's the easiest way to say that the answer is 8.
Okay.
All right. However, that's not how your TA or your instructor would do it. So let's see the way they would do it. So they would say n could be 2. So what are the possible values for L?
L can be 1, 0, or 1.
Good. And then when L can be 0, what are the possible values of m sub L? It might be easier to start with n when L is 1. When L is 1, do you know what the possible values of m sub L are?
When L is 1.
Yeah, what are the possible values of m sub L?
M sub L is the orbitals.
Right? That's one way to think of it.
Is it 1, 0, and -1?
Yeah, That's right. Maybe we talked about this a little last time. The m sub l's are always centered around 0. And they go from negative L to positive L. The possible l's go from 0 to n minus 1. And the possible m sub l's go from negative L to 0 to positive L. All right, now this is a little bit trickier. When L is 0, then what are the possible values of m sub L?
0.
That's it. Because if we're going from negative L to positive L, that would be from negative 0 to positive 0, which is just 0.
Right.
And as you said, each of these represents an orbital. How many different states? Now remember that in an orbital, you can have either of two different spins, 1/2 or negative 1/2. So how many possible states does this actually represent?
2.
And this represents 2, and this represents 2. So how many did we get overall here?
8.
Because there's 1, 2, 3, 4 orbitals, and each of those orbitals has two different possible spins. That's the same answer we just read off the periodic table. I find it a lot easier just to use the periodic table, but that's not the way, unfortunately, teachers usually teach that. They like to focus on these numbers over here. So we can also work it out with the numbers. There's 4 orbitals, and each of them has room for 2 different spins. That would be 8 overall.
Yeah.
And let's still talk about this just a little bit more. When L equals 0, remember that L stands for the subshell. Well, what's the other name for the subshells besides L equals 0 or L equals 1? Well, the other names are S, P, D, and F, right? When L equals 0, what's the letter for that?
S?
Yeah. And when L equals 1, what's the letter for that?
P?
All right, this is just what we already knew. We already knew that the second shell has a 2s block and a 2p block. We could have just read that off the periodic table. There's a 2s block and a 2p block. That's all that it means to say that L could be 0 or 1 over here. And how many electrons fit in the s block? How many electrons fit in the s? 2. So how many orbitals is that?
1.
That's the reason there's only one ml number over here. 1 orbital with room for 2 electrons. And how many orbitals would we have for the p block?
3.
Because there's room for 6 electrons. 6 electrons are 3 orbitals. In chemistry, we would usually call the orbitals px, py, and pz. But again, the physicists really like these numbers here, so instead of calling them px, py, and pz, they call them ml equals -1, ml equals 0, and ml equals 1. But those are just the same px, py, and pz that you might have seen discussed in chemistry. Okay, so we saw how to solve this using the periodic table, but we also saw how to solve it just using these rules for the possible L's and the possible M sub L's. One thing to watch out for is notice, I think when you started you said, oh, if n is 2, then L is 1. But remember, we're not trying to say what L is, we're trying to say what the possible values for L are. So instead of just getting one number for L, we're going to get a list of possible values for L. So with these problems, you always want to check to see whether they're asking us for the actual variable or just the possible values. Okay. Part C is a good part. Were you looking at that, or were you going to move on to something else?
Yeah, but I can't find the question in part C.
Oh, you don't have the next page?
Well, I think I do, but
Here it is.
oh yeah, I do.
Okay.
It's ground state. Is it? I don't know.
Let's look at choice E.
So when an atom is in its ground state, n equals 1, right?
Only if there's only one electron. If there's many electrons, then all the electrons will get to the lowest possible energy level. But they can't all be in the n equals 1, because there's only room for 2 electrons in the n equals 1. So yeah, the point that they're in the ground state, one point of being in the ground state is we can just read the answer off of the periodic table. So let's look at part E. So part E says,
1s2.
so yeah, let's say we were starting to fill the electrons in. Let's use what they call the Aufbau principle in chemistry. Where would we put the first electrons?
In H, in helium.
Well, what I mean by that is in the 1s. And how many electrons will fit there?
2.
2. Well, that seems to match all of the choices, right? All of the choices put 2 electrons in the 1s block.
Right.
So far we're good. Now, where will we put the next electrons after the 1s block?
2s2.
Yeah, the first electron will go in the 2s block. And how many electrons can we fit there in total? 2.
Mm-hmm.
Does that match the choices?
Yes.
Yeah, okay.